Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. Today is Wednesday, January 28th, 2026, and we've got a fantastic lineup of stories for you.
We certainly do. We'll be covering NOAA's new solar observatory reaching its destination, looking back at how weather played a tragic role in the Challenger disaster 40 years ago, and discovering how AI is uncovering hidden cosmic treasures in Hubble's archives.
Plus, Venus might be in for a spectacular meteor shower this July. We'll explore stellar fireworks at the heart of our galaxy, and NASA is giving us a live view of the Artemis II moon rocket on the launch pad.
Let's dive right in.
Our top story today takes us about 1 million miles from Earth, where NOAA's space weather follow-on Lagrange 1 Observatory has just arrived at its permanent home. Anna, this is a pretty significant milestone for space weather monitoring, isn't it?
Absolutely, Avery. This observatory reached Lagrange Point 1, or L1, on January 21st after launching back in June 2024. Now, for our listeners who might not be familiar, L1 is the special gravitational sweet spot between Earth and the Sun, about 1.5 million kilometers from our planet.
And what makes this location so ideal for watching the sun?
Well, at L1, the observatory maintains a constant view of the sun while orbiting in sync with Earth. It's like having a cosmic early warning system. The satellite can detect solar storms and coronal mass ejections headed our way, giving us that crucial advance notice, typically about 15 to 60 minutes before these events impact Earth.
That advance warning time is critical, isn't it? I mean, we're talking about protecting everything from power grids to satellites.
Exactly right. And here's what's really exciting. It's not just one observatory. It's a constellation. NOAA is planning 4 more satellites for L1, plus additional ones at Lagrange Point 5. Together, they'll create this comprehensive solar monitoring network. The second satellite is already scheduled to launch in 2027.
So we're looking at a much more robust space weather forecasting capability in the near future.
Precisely. And given how dependent our modern infrastructure is on satellites and power grids, this kind of monitoring becomes more important every year. The observatory is now beginning what NOAA calls an extended checkout period before it becomes fully operational.
Moving to a more somber note, January 28th marks 40 years since the Space Shuttle Challenger disaster. Anna, there's been renewed focus on how weather and engineering decisions played into that tragedy.
Yes, and it's a powerful reminder of how critical environmental factors are in spaceflight. You know, Avery, the night before that launch, temperatures at Kennedy Space Center dropped to just 28 degrees Fahrenheit. That's -2 Celsius. For Florida, that was exceptionally cold.
And those cold temperatures were at the heart of the problem, weren't they?
They were. Engineers from Morton Thiokol, the company that built the solid rocket boosters, were deeply concerned about the O-rings, these critical rubber seals in the booster joints. They'd never been tested below 53 degrees Fahrenheit, and the engineers warned that the cold could make them too stiff to seal properly.
But the launch went ahead anyway.
It did. Despite the engineering concerns, there was enormous pressure to maintain the launch schedule. NASA had already postponed the mission several times, and there was this institutional momentum to proceed. 73 seconds after liftoff, hot gases escaped through a failed O-ring seal, leading to the catastrophic breakup of Challenger.
It's heartbreaking. 7 crew members lost, including Krista McAuliffe, who would have been the first teacher in space.
The tragedy fundamentally changed how NASA approached decision-making. The Rogers Commission investigation that followed was incredibly thorough, and it led to major reforms in safety culture and communication. One of the key findings was that engineering concerns need to override schedule pressures, always.
And those lessons still resonate today, don't they? I mean, we see NASA taking extra time with Artemis missions, being very methodical.
Absolutely. The Challenger disaster taught us that in spaceflight, there's no such thing as a routine launch. Every mission requires the same level of scrutiny and respect for engineering limits. It's a lesson paid for with 7 lives, and one we must never forget.
On a brighter note, let's talk about some exciting discoveries from the Hubble Space Telescope. Anna,
artificial intelligence has just helped astronomers uncover hundreds of previously undetected cosmic objects in Hubble's vast archives.
This is fascinating stuff, Avery. So, researchers have developed this AI algorithm that can sift through decades of Hubble observations, and it's finding things that human astronomers missed?
Exactly. The algorithm focuses on something called gravitational lensing, when a massive object like a galaxy cluster bends light from more distant objects behind it. Einstein predicted this effect, and it's like having a natural cosmic magnifier.
And these lensed objects can tell us a lot about the early universe, right?
They can. The AI has identified hundreds of gravitational lens candidates, including some exceptionally distant galaxies from when the universe was very young. What's really clever about this approach is that the algorithm was trained on existing verified gravitational lenses, so it knows what to look for.
So it's not just finding more of the same, it's finding rare and unusual examples too.
That's what makes this so exciting. The AI is uncovering exotic lensing configurations that would be extremely time-consuming for humans to find manually. We're talking about complex multi-image systems, arc-like structures, even Einstein rings where the background object is perfectly aligned.
And Hubble has been collecting data for over 30 years now, so there's this enormous archive to mine.
Right, it's like having a treasure trove that we're only now learning how to properly search. These discoveries will help us understand dark matter distribution in galaxy clusters, study extremely distant galaxies that would otherwise be too faint to detect, and refine our models of cosmic evolution.
It really shows how AI and human astronomers can work together. The AI does the heavy lifting of searching through millions of images, and then human experts verify and study the most interesting candidates.
Exactly. It's not replacing astronomers, it's amplifying what they can achieve. And as these AI tools get more sophisticated, who knows what other cosmic secrets might be hiding in plain sight in our archives?
Now for something you don't hear every day. Venus might be getting a meteor shower. Avery, tell us about this cosmic event coming this July.
This is a really cool story, Anna. Astronomers have determined that Venus could experience a significant meteor shower in July 2026, and it all traces back to an asteroid breakup that happened long ago. We're talking about debris from asteroid 2002 VT37.
So an asteroid broke apart, and now its debris is going to hit Venus.
Essentially, yes. When asteroids collide or break apart, they create streams of debris that continue orbiting the sun. Earth regularly passes through these debris streams. That's what causes our meteor showers like the Perseids or the Geminids.
But we don't usually think about other planets having meteor showers.
We don't, and that's partly because we can't observe them as easily. But mathematical modeling shows that Venus's orbit will take it through this particular debris stream in July. The timing and geometry appear to line up for a genuine meteor shower event.
What would that look like? I mean, Venus has that incredibly thick atmosphere, right?
It does. Venus's atmosphere is about 90 times denser than Earth's and is mostly carbon dioxide. Any meteors entering that atmosphere would experience tremendous heating and friction. They'd likely burn up at much higher altitudes than meteors do on Earth, creating bright streaks across the Venusian sky.
Though I suppose nobody's going to be on the surface watching this light show.
No, surface conditions on Venus are pretty inhospitable. We're talking temperatures hot enough to melt lead and crushing atmospheric pressure. But spacecraft in orbit around Venus or even Earth-based observations with certain wavelength might be able to detect evidence of the meteor shower.
Could this tell us anything scientifically valuable?
Absolutely. Studying how meteor showers interact with Venus's unique atmosphere could give us insights into atmospheric chemistry and dynamics. Plus, it helps us understand the distribution of debris throughout the inner solar system. And it's just a reminder that these dramatic cosmic events aren't exclusive to Earth.
Speaking of dramatic cosmic events, let's head to the center of our own galaxy. Avery, astronomers have been observing what they're calling stellar fireworks at the heart of the Milky Way.
The galactic center is such a wild place, isn't it?
I mean, we've got that supermassive black hole, Sagittarius A star, and all sorts of extreme physics going on there.
It really is cosmic chaos in the best way possible. The region around Sagittarius A star is incredibly dense with stars, gas, and dust. And what astronomers are seeing is a spectacular display of stellar activity. Massive stars being born, living out their brief but brilliant lives, and dying in supernova explosions.
And all of this is happening in a relatively small region of space, right?
Exactly. The galactic center is an incredibly compact environment. You've got stellar densities that are millions of times higher than what we see in our solar neighborhood. Stars are packed so tightly that gravitational interactions are common, and the radiation environment is intense.
What kind of observations are revealing these fireworks?
Astronomers are using multiple wavelengths, infrared, X-ray, and radio observations to peer through the thick dust that obscures the galactic center in visible light. What they're seeing are energetic outbursts, shock waves from supernova remnants, and evidence of stars being torn apart by intense tidal forces near the black hole.
That sounds pretty dramatic. Stars being torn apart?
Yes, there's this phenomenon called tidal disruption, where a star that ventures too close to Sagittarius A star gets stretched by gravitational forces, sort of like cosmic spaghettification. The star literally gets pulled apart, and some of that material falls into the black hole, while the rest is ejected at tremendous speeds.
And we're also seeing new stars forming in this extreme environment?
Meteor. Despite the harsh conditions, or perhaps because of them, there are regions of intense star formation. The gravitational compression from all that mass can trigger the collapse of gas clouds, leading to new stellar births. These tend to be very massive, hot stars that burn bright and die young.
It's almost like the galactic center is this constant cycle of creation and destruction.
That's a perfect way to describe it. And studying this region helps us understand how galaxies evolve, how supermassive black holes influence their surroundings, and what conditions were like in the early universe when star formation was much more vigorous everywhere.
For our final story, let's come back closer to home. NASA has launched a 24-hour live stream showing the Artemis II moon rocket on the launch pad at Kennedy Space Center.
This is pretty exciting for space enthusiasts, Avery. The Space Launch System rocket with the Orion spacecraft is now stacked and standing on Launch Pad 39B, and anyone can watch it live whenever they want.
This is the mission that will send astronauts around the moon, right? The first crewed lunar mission since Apollo 17.
That's right. Artemis II will carry 4 astronauts. NASA astronauts Reed Wiseman, Victor Glover, Christina Koch, and CSA astronaut Jeremy Hansen on a journey around the moon. They won't land, but they'll perform a lunar flyby before returning to Earth.
And having the rocket on the pad now, that means we're getting close to launch.
Well, the current target is no earlier than April 2026, though space missions often face schedule adjustments. Right now, the rocket is on the pad for integrated testing, making sure all the systems work together properly before committing to a launch attempt.
What kind of testing are they doing?
They're running through what's called a wet dress rehearsal, which involves loading the rocket with propellants and going through the countdown sequence, stopping just short of ignition. It's essentially a full launch simulation to verify that all systems, ground equipment, and procedures work as planned.
And the live stream lets us watch all this happening in real time?
Exactly. It's a continuous feed, so you can check in at any time, day or night, and see the rocket standing there on the pad. Sometimes you'll catch technicians working, other times you might see weather rolling through. It's a unique behind-the-scenes look at the preparation for this historic mission.
I have to say, there's something awe-inspiring about seeing that massive rocket just standing there, ready to take humans beyond Earth orbit for the first time in over 50 years.
There really is, and it represents years of work by thousands of people. After Artemis II's lunar flyby, Artemis III will attempt the first crewed lunar landing since 1972, including landing the first woman and first person of color on the moon.
It's a new chapter in lunar exploration, and we're watching it unfold in real time, literally. We'll put a link in the show notes if you'd like to check it out.
And that wraps up today's episode of Astronomy Daily. From solar observatories reaching their cosmic outposts to remembering hard-learned lessons, from AI discoveries in telescope archives to potential meteor showers on Venus, stellar fireworks at our galactic center, and moon rockets on the launch pad. It's been quite a journey through the cosmos today.
It certainly has. If you want to stay up to date with all the latest space and astronomy news, make sure you're subscribed to Astronomy Daily. You can find us on your favorite podcast platform.
And don't forget to visit our website at astronomydaily.io for additional content, show notes, and links to all the stories we covered today.
You can also connect with us on social media at Astro Daily Pod across all major platforms.
Until next time, keep looking up.
Clear skies, everyone.
Astronomy.